All right, looking at example 2, we are going to try to factor the equation 2x squared plus 7x minus 3. For example 2, we are going to try to factor 2x squared plus 7x equals -3. To review our steps, the very first thing we need to have happen is we need to set our equation equal to 0, which in example 2, we are not set equal to 0. So that means I need to get that -3 that is on the right-hand side to move to the other side. I want it to be on the other side so the whole thing can be set equal to 0. In order to do that, I'm going to add 3 to both sides. And our equation will be rewritten as 2x squared plus 7x plus 3 equals 0. This is what I am looking for before I start factoring, is it has to be set equal to 0. Now to factor this, I first am going to check for, do I have a GCF? 2, 7, and 3 do not have a GCF, and my leading coefficient is 2. So because my leading coefficient is a 2, I'm going to have to multiply 2 times 3, or A times C. 2 times 3 gives us 6. So I am going to think about factors of 6 that have a sum equal to 7, which is the term in the middle, that positive 7. So things that are going to multiply together to be 6 include 1 times 6. And then if we do 1 plus 6, that does in fact equal 7. So our factors are going to be 1 and 6. So in order to factor this, we have to take into account that we are starting off with a 2 at the beginning. So you can either do reverse box method, or you can set this up with parentheses and start off with a 2x at the beginning of each parenthesis, so 2x plus 1 and 2x plus 6. I'll do the reverse box method in a moment so we can also see what that looks like. And then I'm going to see if I can divide out a GCF from either set of parentheses. 2 and 1 has a GCF of 1, so if I divide that, I still end up with 2x plus 1. But if I divide 2 and 6 by a GCF, they have a GCF of 2, and that leaves me with x plus 3. So 2x plus 1 and x plus 3 is my factored expression. So we set that equal to 0. And now I'm going to break this into 2 pieces and set each parenthesis equal to 0. So 2x plus 1 equals 0, and x plus 3 equals 0. From here, we're going to solve for x in each one. So we want to get x by itself. For the left-hand side, 2x plus 1, that means I'm going to subtract 1 on both sides. And then we'll be left with 2x equals -1. And from there, to get x alone, I need to divide by 2. And so x is equal to -1/2 for the first term. And then for the second term, we have x plus 3 equals 0. I need to subtract 3 on both sides to get x alone. And that gives me x is equal to -3. So my two solutions is -1/2 and -3. Now real quick, I'm going to do reverse box method for those who prefer reverse box method for factoring, so that you can see how we are going to do that. So again, I'm going to put a, which is 2, and then x squared in the top left corner, and I am going to put 3, which is c, in the bottom right corner. And then the factors that we found was 1 and 6, so I'm going to put 1x and 6x in the other two boxes. And then we factor by a GCF for each row and each column. So if I take 2x squared and 1x, and I look for a GCF, the only GCF I'm going to find there is x. 2 and 1 don't have a GCF other than 1. And then if we factor the second column, we have 6x and 3. I can take a 3 out of that, so we have x plus 3 at the top. And then we are going to factor each row. So 2x squared and 6x. 2 and 6 has a GCF of 2. X squared and x, we can take 2x out. And then lastly, 1x and 3 has a GCF of 1. So it's going to be a positive 1. So that is where 2x plus 1 and x plus 3 come into play again. And then we take that and set them equal to 0 and factor.